Hi everyone. I'm doing these videos in an attempt to help people. I don't think I'm better than teachers or anything. I'm just doing this, I'm not entirely up my arse, and if I was, this would be a great comeuppance because I'm currently sitting in my dining room talking to my laptop. So I thought that starting with C6, the electrolysis unit in that anyway, will be a good place to start because it can be ridiculously tricky, and also it comes up in C2/3, I can't remember which, so it will cover a lot of different stuff, which can be quite helpful. Yay. I would just like to apologise for the appalling image quality. My whiteboard kept moving, so yeah, apologies. I thought we'd start with the definition of electrolysis, which is, as you can now see appearing, the decomposition of a liquid by passing an electric current through it. This is pretty self-explanatory. You're essentially breaking down a liquid by passing electricity through it. This is the foundation definition. But to get full marks in a higher paper, you just have to add a little bit more. If you just wrote this down, you'd probably still get a few marks, as long as you're actually answering the question, what is electrolysis? Otherwise, I don't think you're going to get many marks. Punctuation first, guys. Okay, so this is the bit which you have to add if what is electrolysis comes up in a higher paper. You have to know that the current which splits the liquid is produced by the movement of ions, which are found within the electrolyte, which is something that you will see in the diagram next. You also have to know that these ions discharge the electrodes, which is something else that you will also be seeing in the diagram, which is coming up as well with the electrolyte, obviously. This is the diagram for electrolysis in the school laboratory, because the exam board likes trying to make this as accessible as possible while also making it as dull as possible. I've just labelled the electrodes, which are basically rods which have an electric charge. They're called the anode and the cathode. You also have the electrolyte, which is the liquid which is broken down. It has to be able to conduct electricity, hence the electro in the name. I'm also currently labelling the DC power supply, which is the thing which gives the electric charge to the electrodes. I'm currently labelling the charges which are on the anode and the cathode, although my pen keeps malfunctioning. Well, you can't malfunction a pen. And as you can see, once I've finished, the anode and the cathode have opposite charges. The anode is positive and the cathode is negative. The way that I remember this is that I'm an excessively negative person and my last name is Catherine. The reasons that the electrodes have opposite charges is because they are connected to two different sides of a battery. As you know, whenever you're changing the battery on something, there are the positive and negative sides, and if they're not in the right place, then the device won't work. The charge on the actual electrode is the same as the side of the battery it's connected to. For example, if the electrode is connected to the positive side of the battery, the electrode will be the anode. The next thing you need to know is about the two types of ions. The first one we're going to look at, alphabetical order, is anions. Anions, contrary to what you'd think because of the electrodes, anions are actually negative ions, they're the opposite. And I would say that the reason they're called the anion is because anions discharge at the anode. This means that, like me, you only actually have to remember one charge of an electrode, because then if you know that the cathode, for example, is negative, you will know that the anode is positive, so you will then know that the anion is negative, as long as you remember that the charges on the ions and the electrodes are opposite. An example of an anion is the hydroxide ion, and you can tell this because it has a little negative next to it. And this shows that it has a negative charge, so thusly is an anion. Okay, so the second type of ion is called the cation, as you can sort of predict because of the names of the electrodes. They are not made from cats, contrary to popular opinion, and they are also the positive ion, which you would get from the fact that the name of the ion is opposite to the name of the electrode which it discharges at. So from this you can guess that the cations discharge at the cathode. Excuse me while I now adjust my tripod. It's one of those weird tripods which only seems to have weird intermediate phases. There you go. An example of a cation is a hydrogen ion, which is basically just a proton. It has, and like with a hydroxide ion, you could tell that it is a cation because it has a tiny little positive plus next to it and up. And as you can see, I also realised I didn't have enough space to write it's a cation. On to some fun math stuff. Yeah, woo, excitement. Okay, so this is the triangle, which you use to predict the amount of electricity that you can use for electrolysis. And presuming you know how to use a triangle in that you cover up the thing that you want, and if they're next to each other you multiply, and if you need to, and then if they are on top of each other you divide the one on top by the one on the bottom, and the actual equation is quantity of electricity equals time times current. What does this mean for electrolysis? You basically just have to use your common sense. It's a multiplication equation thingy, so if you ran the reaction for longer, or used a stronger current, then that would mean that you'd be supplying more electricity, so therefore you'd be producing more current at the end of the reaction. And to emphasise this, I've written this in block capitals. The other bit of maths which you have to know about is that to produce 1 mole of 1+ ions, so positive ions, which are cations, remember, you have to use 96,500 coulombs of electricity. I will also just say that any oboe music in the background is my sister, and it is completely unintentional. She just has a really loud oboe. I'm now going to flash that number up a few times just to emphasise it, because it is very important, because it can help you do calculations. For example, if you were told that a particular reaction has produced 3 moles of, say, silver ions, then you would know that you have to multiply 3 by 96,500 to find out how much electricity would have gone into it. Okay, the next thing you have to know about is how electrolysis works with ionic solids and solutions. And of course the key with this is that it's ionic solids and solutions. So in an ionic solid, all the ions, which are charged particles, are held together by very strong ionic bonds, and within these they are fixed in position. So when electricity comes by, it can't actually get through and the particles can't move. For example, it's like when you're sitting in a cinema in a row and someone partway through the row is late, shows up while everyone else is sitting down, and you're a little bit annoyed when you have to stand up. In an ionic solution, this isn't a problem because it can move, because all the particles, they're not fixed in position and can move around and be free and conduct electricity. You also have to know about specific cases of electrolysis, and these are sodium hydroxide and sulfuric acid. You have to know that in the electrolysis of both sodium hydroxide and sulfuric acid, oxygen is produced at the anode and hydrogen is produced at the cathode. The way that you may remember that is that oxygen and anode both begin with vowels and sort of matches up, I guess, or you could just remember it. You know the half equations for these electrolysis cases. At the cathode, it is 2H plus 2E minus turns into H2, hydrogen. The reason that it is 2 is because hydrogen is diatomic, so it prefers to have 2 atoms bonded next to each other. This is something you're just going to have to accept and remember, unfortunately, but hey, whatever. Also, the E minus, that stands for electrons. The equation of the anode is 4OH minus 4E minus turns into O2, which is oxygen, plus 2H2O, which is 2 water. You can also write the electrons on the other side of the arrow in the way which I've written underneath the top equation. And I think you should probably get marks for both. There's the sulfate in the case of sulfuric acid, or the sodium in the case of sodium hydroxide go? Well, the answer is that it just remains in the solution, the electrolyte. The reason that it is sodium or sulfate that remains in solution is similar to what would happen if you were set a reading assignment in, say, English, and you were told you could read either Hunger Games or War and Peace. Obviously you're going to probably, unless you are particularly fond of Russian literature, probably going to choose Hunger Games because it is quicker and simpler, and that is why the oxygen and the hydrogen is what is produced. They are easier, and of course where does the oxygen and hydrogen come from? The actual compounds themselves are aqueous. This means they are surrounded by water, and in most cases it's actually easier to break down the water than to break down the compound that the water is surrounding. They also like you to know about the chemical tests which you do to find out if you have different gases being produced. If you have hydrogen, you will hear a squeaky pop if you put it in the presence of a glowing splint. With oxygen will relight a glowing splint. What you have to know about is the electrolysis of copper sulfate. There's a bunch of factual recall for stuff, so I just decided to put it all on the same thing. You have to know that carbon electrodes are used for this, and the way you can remember this is that it's copper and carbon and they begin with the same letter. You also have to know that copper is produced at the cathode, and again, copper, cathode. I don't know, that might work for you, might not, you might just want to just remember it. And you also have to remember that oxygen is produced at the anode, and this is the other vowel thing which I mentioned earlier. If you haven't remembered it from then, it might just be worth remembering stuff. You also have to remember the following observations from during the electrolysis. You have to remember that the cathode will become plated with copper, which is basically common sense. You also have to remember that there are going to be bubbles formed at the anode because the oxygen is there. Again, that's more common sense. And you also have to remember that the blue colour of the copper sulphate itself is slowly going to disappear as the copper is plates the cathode. More fun half equations to remember. At the cathode, you have Cu2+, Cu is the symbol for copper, plus 2 E- electrons forming copper. In this, I have got the electrodes around the wrong way. Copper is formed at the cathode, not the anode. And the half equation at the anode is the same as it was for sodium hydroxide and sulfuric acid. And again, you can write it with the electrons on the other side of the equation. It just depends on how you like to write it. And just to emphasise, this is at the anode, not the cathode. I got it wrong. With all these different products forming according to whatever you're doing, how can you actually predict what will form where? There are actually some genuine rules behind it. At the cathode, you will always form either a metal or hydrogen. For example, in the electrolysis of sulfuric acid, as we have seen, hydrogen is formed. The way to predict whether the metal or hydrogen will form is down to the order of reactivity. Anything that is more reactive than hydrogen isn't going to form if hydrogen is present, which of course it is because anything that is electrolyzed is in aqueous solution. So if any of these are present, those metals are not what forms at the cathode. Yeah. Anything below hydrogen on the scale of reactivity, which are basically just copper, silver and gold, these have priority over the cathode, so will form if they are present at all. I think you can obviously try and remember all the metals that are more reactive than hydrogen. I haven't actually written all of them up there because I didn't have space. But I would personally say that it's probably just easier to remember the 3 below hydrogen, which are copper, silver and gold. But what about the anode? Again, there are rules to this as well. It is always a non-metal. Brings us back to the Hunger Games or War and Peace analogy. If in the electrolyte you have sulfate ions, as well as the oxygen ions, which are present in the water surrounding the compound because it's an aqueous solution, the thing that is produced at the anode is going to be the simpler molecule, and obviously I'm hoping you can tell it is oxygen. Electrolysis essentially is lazy. It tries to do as little work as possible, so we'll always go with the easiest solution. So, thanks for watching. If you made it this far, well done. If you could leave some stuff in the comments, that'd be great, just to give me some feedback. If this was actually useful for you, please tell me because that'd be really cool. If there's stuff that you want me to improve, I'm sure there's a lot you want me to improve. This is my first one, so they will hopefully improve in the future. But any sort of suggestions, please leave them in the comments. If you didn't understand anything, just ask some questions and I'll try and get back to you with those. You can also contact me on Twitter with questions and stuff. I'm @EllaZinc. Also, if there are any other units in anything else that you want me to prioritise, then please tell me those too. Also, because the best way to learn stuff after you've learnt it is to test yourself, I have set up a Quizlet for the whole first part of C6. It's on my Quizlet, which is zinc manganese, no caps, and it's called C6 and in brackets C6 part 1 and in brackets better. So yeah, thanks for watching, and yeah, woohoo!